Hello and welcome, Cambridge Advanced Level Mathematics here. We are back to our normal routine. Today I've got a question from paper 1, 2022. It's question number 3 and it reads as follows. The coefficient of x to the power 4 in the expansion of 2x squared plus k to the power 2 over x all raised to the power 5 is A. The coefficient of x squared in the expansion of 2kx minus 1 raised to the power 4 is B. Find A and B in terms of k. What does this mean? This means that when we expand this thing, the term that contains x to the power 4, the coefficient of that term is equal to A. Whatever it is, it will be in the form of k, this and that, but we can equate it to A. Same applies here. When we expand this, we look for the term in x squared, the coefficient of that term is equal to B. So find A and B expressed in terms of k. Of course, all this is talking about the binomial theorem, and we did talk about the binomial theorem in previous videos. But I'm just going to give you a summary of what the binomial theorem looks like here before we get into the question. If we have something like A plus x raised to the power n, or raised to the power n, this is equal to A to the power n plus n brackets n a to the power n minus 1 x plus n brackets n minus 1 a to the power n minus 2 x to the power 2 all over x 2 factorial plus n brackets n minus 1 all the way up to n minus r plus 1 x to the power r, all this over r factorial all the way up to x to the power n. That's the binomial theorem. These are coefficients of the terms. These are coefficients of the terms. Another form of the binomial theorem is A plus x to the power n is equal to A n plus n1 a to the power n minus 1 x plus n2 a to the power n minus 2 x squared n r x to the power, a to the power n minus r x to the power r all the way up to x to the power n. Now, equation 1, this form of the binomial theorem, the first one, is suitable for when we want to expand a series to a few terms, for example. The second form here is used when we want to find a particular the coefficient of a particular power of x. But I will explain this n2, nr business. What it means is that we can, of course, get rid of all this. I will put a little formula at the corner there to represent this, so when we get to solving that, we can always be checking on it. Let me explain this n over r notation. when we have n over r, oh, sorry, it's not n divided by r, so I almost got it wrong. N over r, it means n factorial divided by n minus 1 minus r factorial r factorial. For example, when n is equal to 5 and r is equal to 2, then we have 5, 2, okay? N is 5, r is 2. This is equal to 5 factorial divided by 5 minus 2 factorial, which is 3 factorial, divided again by 2 factorial, which is our r there, or 2 factorial. That's the meaning of 5, 2. Right. Now, in this particular example, we are supposed to be finding the term that contains x to the power 4. Now, obviously, a general term in the expansion of that binomial expression will be, a general term will be 2x, yes, 2x squared, 2x squared, which represents our a, 2x squared raised to the power n minus r multiplied by k squared over x raised to the power r. This one stands for x. Right. That's the general term in the expansion. But we want it to be such, the term we are looking for will be such that x is raised to the power 4. But we have an x up here and an x down here. The x upstairs, the x squared actually, is raised to the power n minus r. And the x down here is raised to the power r. So at the end of the day, we're going to subtract the powers. And when we are done subtracting, it should be equal to 4. Let's simplify the top and write it as, this will be equal to 2n to the power minus r, to the power n minus r, multiplied by x, also to the power, now the powers will multiply, it will be 2 brackets n minus r, that's the power of x there. Of course, now with this one raised to the power, k raised to the power 2r divided by x raised to the power r. That's what everything is going to look like. Okay, but we want this power combined with this power, the 2n minus r combined with this to equal 4. So in other words, we know that when you divide, the powers are subtracted. So therefore, we can write that 2n, 2 brackets, n minus r minus this r should be equal to 4. Simplifying, removing the bracket, we have 2n minus 2r minus r is equal to 4. 2n minus 3r is equal to 4. But what is n? N is 5. So this gives us 10 minus 3r is equal to 4. Subtracting 10 from both sides, we get minus 3r is equal to minus 6, so that r is equal to 2. So our r there will be equal to 2. Okay, so what happens now? So our term now that contains x squared, let's clear this. The term that contains x squared will be the term that has, of course, it will be nr, which will be, our n is 5, which is 5, 2. We found that our R is 2. 5, 2 multiplied by 2 to the power 5, 5 minus 2, which is 3. And x raised to the power 2 times 5 minus 3. 2 times 5 minus 3, minus 2, sorry, which is 3 times 2, which is 6. Okay? 2 to the x to the power 6 multiplied by k to the power 2 times that is 4. Divided, of course, by x to the power 2. Okay? Before we deal with this, let's just go through this and check that we did the right thing. We calculated our R to be 2. So here we will have 5 minus 2, it's 3 there. Then we will have 5 minus 2, which is 3 times 2, which is 6 there. And of course, 2 times 2, which is 4. And that gives us our x squared there. Let's simplify. This becomes 5, 2 multiplied by 2 to the power 3. 6 minus 2 is x to the power 4 as required. K to the power 4. Let's calculate our 5, 2. 5, 2, I think we got it as what? Okay, let's find it out. 5, 2 is equal to 5 factorial divided by 5 minus 2 factorial, which is 3 factorial, divided by our 2 factorial, these two here. Remember, here you must have n minus r. In this case, our n is 5, and our r is 2. So 5 minus 2 gives you 3 there. And then, of course, the r factorial, which is 2. So we will have 5 times 3, 4 times 3 times 2 times 1 divided by 3 times 2 times 1 times 2 times 1. So the 3 factorial here cancels that 3 factorial, and we are left with 5 times 4, which is 20, divided by 2, which is equal to 10. Okay, so let's come back to our term there. We now know 5, 2 is equal to 10. So we can write this as, we can simplify this thing there. That becomes 10 multiplied by 2 to the power 3 is 8, multiplied by 8, k to the power 4, x to the power 4. So that gives you 8, k to the power 4, x to the power 4. So in other words, the coefficient of the term in x to the power 4 is this. And they are saying this is what is equal to A. So somewhere here, we can just keep the result because we are going to need it. There's a part of this question which I couldn't fit on the board. I will read it out to you. But it's going to need this thing here. So we can straight away now write 8k to the power 4 is equal to A, as given by the question there. Now let's deal with our second part of the question there. Right, it says the coefficient of x squared in the expansion of 2kx minus 1 to the power 4 is B. So our expression is 2kx minus 1 to the power 4. Our general term, as before, will be, it will be 2kx, I beg your pardon, it will be nr bracket 2kx raised to the power n minus r multiplied by minus 1 to the power r. Of course, we want the term in x squared, so what will be r? If it's the term in x squared, then n minus r is equal to, we should have n minus r is equal to 2. But what is n? N is equal to 4. So 4 minus r is equal to 2. R is equal to 2. So that will give us, we can fit in everything there. It then gives us, we have 4, R is 2, multiplied by 2k x, n minus r is 2, minus 1 to the power 2, which of course is just 1. Then we are left there with 4,2. Remember, 4,2 is equal to 4 factorial over 4 minus 2 factorial over, again, 2 factorial. That gives you 4 times 3 times 2 times 1 divided by 2 factorial there, 2 times 1 divided by the other 2 factorial times 2 times 1. This cancels that, and we are left with 4 times 3, which is 12, divided by 2, which is equal to 6. So we now have, we can clear that. So our 4,2 is 6. So here we can write, this is equal to 6 for this, multiplied by 2 squared will be 4, multiplied by k squared x squared. This is equal to 24k squared x squared. The coefficient of x squared, again, is equal to that. So we can write 24k squared is equal to b. That's what the question says. The coefficient in x squared is equal to b. There is a part which I couldn't fit on the board, but I'll read it for you here. It's simple. It says, given that a plus b, let me clear this board first of all. Okay. It says, given that a plus b, they say a plus b is equal to 216. Find the possible values of k. It says the possible values of k. You must be careful with that. Right, let's see. A is that, b is that, so that must be equal to that. So we can write 80k to the power 4 plus 24k squared is equal to 216. It's equal to 216. Right. We can, of course, bring the 216 over this side. So if 80k to the power 4 plus 24k squared minus 216 is equal to 0. Let's convert this to a quadratic equation, because this is an equation in k to the power 4. So let k squared equal to t. So if k squared is equal to t, this becomes 80 t squared plus 24t, k squared is t, minus 216 is equal to 0. I'm sure, I don't know, maybe we can divide by 8 there. Let's see if 8 goes into 216. 216 divided by 8. Yeah, it does. It goes 27 times. So here it goes 10 times, 10t squared. Here it goes 3 times. So that's 3t there. Here we said it goes 27 times. Let me just check it. 216 divided by 8. Yes, it's 27 times, which is equal to 0. Now we can use the quadratic formula, can't we? So, quadratic formula. So let's write, you can use the quadratic formula there. So t is equal to minus 3 plus or minus the square root of 3 squared, which is 9, minus 4ac, but this one is minus, so it becomes times 4 times minus 27. So it will be 4 times 10, which is this 10 here, 4a, which is 40, times 27, which is that. So plus 1080. It becomes plus because it's actually, the 27 is negative, divided by 2a, which is 2 times 10, which is 20. Okay, let's see if this simplifies. So that gives us minus 3 plus or minus the square root of 1089, all this over 20. 1089, 1089, square root of that, square root 1089, which is that. It's 33, the square root of this, which is equal to minus 3 plus or minus 33 over 20. That's a funny number, isn't it? So then we get 33 minus 3, which is that. So it's either 30 over 20, which is equal to 1.5, or maybe let's write it as 3 over 2, or it's 33 plus 3, which is that, or it's minus 36 over 20, which could be what? Divided by 4, there will be 9, which is minus 9 over 5. Minus 9 over 5. Those are the values of t. But the question says, find the possible values of k. Now, we said k squared is equal to t. So, if t is equal to minus 9 over 5, that is impossible because we don't have square roots of negative numbers. So the only possible value of k is equal to the root of 3 over 2. That's the only possible value. This one is impossible because it gives us an imaginary number. That's the question for you, the binomial theorem. It's really more of a revision question because we dealt with a question on the binomial theorem a few videos ago. But there's nothing wrong in making sure what we have learned sticks. We encourage you to, as always, to subscribe and press the like button. It's very helpful to us. Till next video. Thank you very much indeed.